Hi everyone, I'm really excited to be here. The title of my talk is Building Highly Performant Animation in Elm. My name is Abadi Kurniawan, and my pronoun is he, him, his. And I work at a local company in St. Louis called 1904 Labs. We don't have client work writing in Elm yet, but we do have Innovation Hour, and that's where I get to spend all of my Innovation Hour building Elm code and working on, in this past couple of months, I'm working on this particular talks using my Innovation Hour. And we're hiring, so if you're in St. Louis, come talk to me. So let's get started. So this is a caterpillar, and she's a very happy caterpillar. As you can see, she's smiling here. And the reason why she's so happy is because if you look at this, at the top corner here, we have this thing called frame per second. So if you're not familiar with animation terminology, a frame per second is basically how fast a computer can render your screen every second. So the way animation works in computer is that it just basically changes the image very quickly so that you can see that the image is kind of like, looks like moving, but it's actually just changing it very quickly. And the higher the frame per second, the smoother your animation is going to look like. And the lower the frame per second, the choppier the animation will look like. So, and right now, still frame per second is very high because really nothing is moving on the screen. So it's very easy to get high frame per second. So let's get things moving. So now she's moving along this beautiful field. You see the cloud is also moving. The sun is also moving, and the sun is also very happy. And as you may notice, the frame per second drop a little bit from around 60 to 40-ish. And the animation looks still pretty smooth. As long as you can get the animation to higher than 30 frames per second, usually you can't really notice the choppiness in your animation. So let's get things more interesting. So we add a bunch of other stuff in here. We put drop shadow everywhere. That's how you get your animation to be like very, very choppy, just drop shadow everywhere. And then you can notice that here at the bottom also we have this slightly moving grass. It looks cool, but now she's sad because now our frame per second dropped to 15. And even the sun is sad, like, I don't know what happened to his glasses. So that's not good. Let's try to fix this. So I'm gonna take you to the journey through this animation lens, and we're gonna explore 3 different approaches in writing animation in Elm, and then we're gonna compare which one that we think is the best solution. The goal of this journey is we're just gonna explore ideas of ways of doing animation. And we want to build the high-performance animation. That's one of the main goal here. And of course, we want to make our caterpillar happy again. I think that's the most important goal. What's not the goal of this talk is I'm not here to teach you best practice because honestly, I don't know if this is going to be a good thing or not. But I'm going to leave it to you. This is my way of just an idea that I want to explore. Might be actually turn out to be a best practice because we're going to try to stick to using web standards. So we'll see. And then this is not a finished solution, so I'm not publishing any package. There's no like big, NPM package published live on stage right now. So, and this is like not complete. This is just I'm hacking it for this talk. So that's not the goal. And this is going to be focusing on the DOM animation. So we're not doing WebGL, we're not doing Canvas. If you want to learn more about WebGL, Ian McKenzie will have a talk about 3D rendering in Elm. I'm super excited for that talk. So let's explore the first land, and I call this land the land of pure Elm. Sounds good. So this is an example of how I normally do animation in Elm. So in the past, I've built a couple of simple games in animation, and every time I have to work on the animation part, I'm always struggling to get started because I always try to it's not very intuitive for me because Okay, so let's just look at this. So this is a very simple animation. The apple is moving from left to right. And the way you normally do animation in Elm is that you subscribe to animation frame. And then, so basically what animation frame is that's the browser rendering happening. So it's like every tick of the browser need to update the screen, you get a message from the browser like, oh, things need to be updated. So if you subscribe to that, it means that you know when you need to update the location of this apple, because we want to move it from left to right. So in our model, we have this position of this apple, and again, all of the code that I'm showing today is going to be simplified. So don't just copy paste and then try and hope that and then run it in your program because it won't even compile. But it's here so that we can understand it better. So we have this x position of the apple, and then we start. Initially, we're going to start the x as a 0, and then on every frame, animation frame, we're just going to add the position of the x so it's moving, so it's keep going on every tick. And you need to set up the speed, and you need to do all of this math. Like, it's fine if it's a simple animation, but once you have really complex animation, it's getting more, it's hard to understand. And every time, if you look at this code, you don't immediately know that this apple is moving from left to right. You have to do the math in your head, like, oh, every tick, it's going to move to the right. Then if you need to do multiple animation and you need to synchronize between those two animations, it's getting a little bit more complicated or cumbersome. So in this example, we have this apple. First apple is moving, and then after the first apple is done, the second apple is moving. Let's take a look at that again, like that. So now we have to keep track on how long has the animation run. So we have to have this in our model. We add this time elapsed, and then we check if the time is still under 1 second, then we're going to move the first apple, and then when it's over 1 second, then we're going to move the second apple. And so basically, if you want to synchronize multiple animation that make sure that the second animation happen after the first one is done, you have to manually set the timeline, and you have to, like, by hand, make sure that they all align properly, which is probably fine. But if you have really complex animation, then that's not easy to do. The pros of this approach, honestly, I can't really think of a real pros, so I just put, like, this is pure functional. I guess everybody likes pure functional, right? So it must be good. I don't know. The cons, to me, in my personal opinion, it's pretty cumbersome. Like, again, it's not very intuitive. You look at the code, you don't really see what's going to happen. And we can't use the browser optimization in this case. And the reason why we can't is because the browser doesn't know what's going to happen in the future with your animation. Because you basically tell the browser, you need to do this every tick. So yeah, that way the browser, if the browser knows the future, then the browser can optimize your animation, knows how to render this in the most optimized way. And then the third one is, in the current state of the debugger, it's basically make the debugger useless, because you subscribe to animation frame, you got this, your debugger will be flooded with these messages from your animation frame. So I'm gonna try to explore this idea that I call animation as a side effect. And then the second land that we're going to explore is the CSS animation land. So in this CSS animation, we're basically going to use a CSS keyframe animation. And this is an example of a very simple keyframe animation in CSS. So what here is on the first part here, we declare a keyframe animation. I call it my animation. And we're going to do a transform of a translate, which is moving a position of a thing that you're going to move first position is 0 to 0, and then we're gonna move it to 0 to 100 pixel, x, y. And then we're gonna apply this keyframe animation to a DOM element. So in this case, we're gonna apply it to a div with a class of apple. We wanna run that and run it for 1 second. So my idea of this CSS animation library here is that we're just gonna use this, so basically you write this, you use this library, and then it will produce a keyframe animation for us. But I wanna introduce a different API so that we're not just writing a CSS keyframe animation. So here, an example here is that with my experimental library here, so let's say we want to move this div. We pass it through this animation.width, and we provide with the keyframe animation. So this is an example of you want to apply 2 different animation to a single element. So first we do translate y of 100 pixel for 1 second, and then we want to apply at the same time opacity changes from 100% to 0%. It's going to fade out in 2 seconds. And the generated CSS that this code is going to produce, and then we're going to put it into our div element. And then what happens if you want to do a sequence of animation? So for example, you want to move on x-axis, and then you want to move on the y-axis. So we introduced this API called animation.sequence. Basically, if everything that you pass in this will be sequenced. So in this case, we're going to translate y 100 pixel for 1 second, and then after that's done, we're going to translate x to 100 pixel. And this will automatically produce the keyframe, appropriate keyframe animation with the appropriate timeline calculated for us, depending on, based on your duration that you set up in the animation. Then what happens if you want to do multiple animation again, and you want to coordinate between the two? You can still do that, but now we have this animation.delay. So basically, it's similar to how we do it with the Elm approach, but now it's easier to read, but you still have to manually make sure that the timelines align properly. So in this case, you run the first one for 2 seconds, and then you run the second one, and you put delay for 2 seconds, so that way you're waiting until the first one is done, because they're both 2 seconds. So if you change this one and you forgot to change this one, it won't align properly again. So that's not great. Let's look at an example for this one. So a little bit fancier now. We have more interesting animation happening here. So the first apple, we do the sequence animation, and then we put this translate 500 pixel, and then move down 300 pixel. And on the second apple, we put delay, and we're combining animation instead of sequencing here. So we combine the translation animation, and we combine the opacity animation, and we put delay on both, so that it only happened after the first apple finished moving on the x-axis. Let's take a look at it again. Now the second one is done. So what's the pros on this approach? I would say it's highly performant because it uses the browser animation engine. So CSS, keyframe. So browser knows how to optimize all of this animation. So yeah, we just get that for free. We don't need to do some magic coding or something to make it performant. Just let the browser handle it. And it's very declarative. You look at the code, you know exactly what's going to happen. You know, oh, this thing is going to move here and for 2 seconds. So you can already imagine that in your head. Like, you don't have to do the calculation yourself. Just know this is what's going to happen. We still have some manually synchronizing multiple animation. You have to make sure that it's aligned properly. So I think we can do better. So the third land that we're going to explore is I call web animation land, also known as JavaScript land, because we'll be playing in JavaScript. Hooray. So if you're not familiar with web animation, it's a standard, web standard. So it's a JavaScript API for accessing the browser animation engine. So you get to access the same animation engines that used by CSS. So you got all of this performance optimization, hardware accelerated, all the good stuff. So here's an example of what the web animation API look like. It's very similar in terms of the syntax with the CSS keyframe animation. So basically you get the element here, and then you do the animate on the element, and you pass in your keyframe animation, and then you pass in the option of what your animation is going to be, like duration, what's the fill, how many times you want to run this animation, that kind of stuff. So it's kind of like combining the two CSS into one API, which is nice. Since we're going to be working with JavaScript, so we need to have some interrupt with JavaScript. And two ways of interrupt with JavaScript is through port and web component. And we're going to compare which approach that we think is the better approach for this case. So let's say we use a port. And with port, you kind of have one channel to go into JavaScript and one channel to go into Elm to communicate between the two parts. So if you have two animation, in this case, Apple 1 and Apple 2, and you want to send the keyframe animation to run Apple 1, you have to make sure that when you send that through port, you tell or you give some kind of like ID that, oh, this animation is for 1. And same thing if you have an event coming from your animation into the Elm, you also have to tell, oh, this, let's say this unfinished, this happened for Apple 1. So you have to have a unique ID for each element that you're going to animate. Might be fine, but it's, you have to make up an ID. I don't know, it's not great. I think the web component approach or custom element is a better approach in my opinion, because so with web component, you kind of like wrap every single element that you are going to animate with a web component, and each of that has its own kind of like channel to communicate between Elm and your JavaScript via your attribute and or props, and via event coming from the web component. So in this case, if you want to just tell this Apple to run, you just send that keyframe into this web component instead of this one, and then it will run it. And then when it's done, it will dispatch an event, and then now we can listen to that event in our Elm code, so we know exactly this is happening for this Apple kind of stuff. So it's easier to coordinate between multiple elements that you're going to animate. If you want to learn more, oh, the video doesn't show up. Okay, if you want to learn more about web component, Luke Westby has a very great talk about when and how to use web component with Elm. It's from Elm Europe 2018. I highly recommend watching that. So the workflow here is that we're going to run. So from our Elm animation, from our Elm code, we will pass this keyframe, and this keyframe will run it into a JSON encoder, which will produce a JSON, and we pass this JSON into our web component via the attribute. And then from the web component, we listen to that attribute changes, and then we got the keyframe back, and then now we can pass it into a JavaScript, and JavaScript will run that keyframe into a web animation, into the web animation API. So this is how you tell the element to move or to animate. And then the other way around, if you want to listen to animation event, for example, we want to know when this animation is finished, we're going to subscribe to this on animation finish for that animation, and then inside of web component, we're going to dispatch a new event. So that way we can, inside of Elm component, we can just listen to that, and then we can tag with a message, and then we can do something about that. So here's an example of a single animation. It's the same animation that we've seen before. And then this is what the code looked like with this. Again, this is an experimental library that I wrote. So basically, this Apple is the thing that we're going to move, and we're going to wrap it with this animation.node. And then this, and then you pass in the keyframe animation. So in this case, we're gonna pass in, first you're gonna start with 0 to 0, and you wanna move that to 500 to 0. So move it like that. And then we pass in the option for this animation, how, the duration and the fail and that kind of stuff. So the API here, I designed it to be very close to what the web animation API looks like. I think we can probably use the same approach that we've seen before with the CSS animation, and then have that to be more better API. I don't know, but this is, just want to explore this part first. And then, so this is where it gets interesting, in my opinion. So we want to do that multiple animation again, but now we can listen to on finish event on the first apple. So in this one here, we have this apple, and we attach an onFinish event, and then it will dispatch this first apple animation finish message. And now in our application, we can kind of like maintain our animation state. So we have sorry. So we have this animation state. We can say, oh, the first apple is moving, or if it's time for the second apple to move. And then on this, when the first apple animation finish is dispatched, is fired, then we can change the animation state. So we know, oh, the first one is finished. We need to change the state so that the second apple can move. And then when in the second apple view, view here, we just check whether it's time for the second apple to move, or it's still the first apple is still moving. So I think the code looks better. You can definitely follow along quite easily what's going to happen. And yeah, so the process of this approach is it's also highly performant because it uses the same browser animation engine. And it's declarative. You see the code, you know what's going to happen. And now we simplify the way we synchronize both animation, because now we can listen to animation event from the element that we animate. The cons is browser support. Currently, Web Animation API is only supported on Firefox and Chrome. There is a polyfill for this. I haven't tried it, so I don't know how well the performance of the polyfill, but it's there if you want to play with it. So let's look at the caterpillar again. So this is still the old way of, the Elm way of doing just the pure Elm approach of this animation. So still very sad. Let's see, now it's running with this Web Animation API. And we got, come on, 60. 60, so we got 60 frames per second here. Everything looks smooth. So yeah, I think we accomplished our goal. So what's next? I personally want to see this explore more. I want to implement all the API, the Web Animation API in this library, and hopefully it's not becoming experimental library anymore, but I don't have a lot of free time. So if you think this is a good idea and you want to collaborate with me, come talk to me during the break, or tomorrow I'll be also on Strange Group. You can just say hi to me and we can talk, or you can reach out to me on Slack, GitHub, and Twitter. And if you want to look at the code, it's available on my GitHub. It's abadi199/elm-animation-exploration. Thank you.